Measurement and testing. Test construction, item writing, item analysis. Item writing, whether it's psychology, sociology, or other educational research, writing test items is a matter of precision and is solely based on certain common or general guidelines for all test types. These are: first, the test item should measures the intended learning outcome. 2. The test item should be written in such a way that the performance it elicits matches the performance in the learning task. 3. The main requirement for an item to be considered good is that the test items should be clear and definite. 4. The test item should be free from non functional material as it tends to lower the validity of the item. 5. The test item should not include irrelevant factors as it prevents an informed participant from responding correctly. 6. The test item should not be too easy or too difficult to answer at. 7. The irrelevant cues in the test item should be avoided as it decreases the difficulty level of the item and make it easy for participant to answer correctly. 8. The test item should include any stereotyped word either in STEM or in the alternative responses as it facilitates rote learners in guessing the correct choice or answer. 9. The test item should be written in such a way that there is no disagreement concerning the answer. 10. The test item should be written far enough in advance as whenever required it can be reviewed and modified as needed in future. As far as multiple choice items are concerned, it consists of a problem known as the stem and a list of suggested solutions known as alternatives. The alternatives consist of one correct or best alternative, which is the answer, and incorrect or inferior alternatives known as distractors. The basic rules for writing multiple choice items are as follows. First, each item of the test should be designed in such a way that it measures an important learning outcome. 2. The stem should be meaningful by itself and should present a definite problem. 3. State the stem of the item in simple, clear language. 4. The stem should not contain irrelevant material which can decrease the reliability and the validity of the test scores. 5. State the stem of the item in positive form whenever possible. 6. The stem should be negatively stated only when significant learning outcomes require it. 7. The stem should be a question or a partial sentence. 8. Make certain that the intended answer is correct or clearly best. 9. Make all alternatives grammatically consistent with the stem of the item and parallel in form. 10. Alternatives should be mutually exclusive. 11. Make the distractors plausible and attractive to the uninformed. 12. Alternatives should be stated clearly and concisely. 13. Alternatives should be homogeneous in content. 14. Avoid verbal clues that might enable student to select the answer or to eliminate an incorrect alternative. 15. Avoid using the alternative all of the above and use none of the above with extreme caution. 16. The alternative should be presented in a logical order, for example, alphabetical or numerical, to avoid a bias towards certain positions. 17. Control the difficulty of the item either by varying the problem in the stem or by changing the alternatives. 18. Keep the specific content of items independent of one another. 19. Use an efficient item format. 20. Break or bend any of these rules if it will improve the effectiveness of the item. Item analysis. Item analysis is a set of procedure used to identify the effectiveness of the test items. It is basically applied to know the validity of the items. The Items which are valid and fulfill the purpose of the test are selected, and rest are either modified or eliminated to match the purpose. The validity of the whole test is dependent upon the validity of the individual items. Item difficulty. The first step in item analysis is to find out the difficulty value of the item, or the index of difficulty P of an item. This index is determined by calculating the proportion of examinees that answer the item correctly. A high percentage indicates an easy item question, and a low percentage indicates a difficult item. In general, items should have values of difficulty no less than 20% correct and no greater than 80%. Discrimination index. The item discrimination index D, also known as the item validity index, is another important aspect in item analysis. For this calculation, we divide the test takers into three groups according to their scores on the test as a whole. An upper group consisting of the 27% who make the highest scores, a lower group consisting of the 27% who make the lowest scores, and a middle group consisting of the remaining 46%. The discrimination index ranges between -1 and +1. The closer the index is to +1, the more effectively the item distinguishes between the two groups of students. When D is 1.00, all test takers in the upper group and no test takers in the lower group answered the item correctly. Conversely, if none of the upper group but all of the lower group answered an item correctly, the D value would be -1.00. Both of these circumstances are rare, and we will probably never see a value of -1.00. Item characteristic curve ICC. This is a graphical or pictorial depiction of the probability of giving the correct answer to an item as a function of the level of the attribute assessed by the test. In the item characteristic curve, the total test score is represented on the horizontal axis, and the proportion of test takers passing the item within that range of test scores is scaled along the vertical axis. The probability of correct response is near zero at the lowest levels of ability. It increases until at the highest levels of ability the probability of correct response approaches. First, this S shaped curve describes the relationship between the probability of correct response to an item and the ability scale. In item response theory, it is known as the item characteristic curve. Each item in a test will have its own item characteristic curve. There are two technical properties of an item characteristic curve that are used to describe it. The first is the difficulty of the item, and the second is the discrimination. The steepness or slope of the ICC conveys about the discriminating power of the item. The steeper the curve, the better the item can discriminate. The flatter the curve, the less the item is able to discriminate, since the probability of correct response at low ability levels is nearly the same as it is at high ability levels. Using these two descriptors, one can describe the general form of the item characteristic curve: test, standardization, reliability, validity, and norms. Reliability. In the psychometrics, reliability is the overall consistency of a measure. According to Anastasi, 1968, reliability refers to the consistency of scores obtained by the same individuals when re-examined with test on different occasions or with different sets of equivalent items or under other variable examining conditions. For estimating the reliability coefficient of test scores, the three most common methods are: first, test retest reliability; two, internal consistency reliability; three, parallel form reliability or alternate forms reliability. Test retest reliability. In test retest reliability, the same test is administered to the same sample on two different occasions with a reasonable time gap, which yields two independent sets of scores. When correlated, these two sets give the value of the reliability coefficient, which is also known as the temporal stability coefficient, and thus indicates the extent to which the examinee retained their relative position as measured in terms of the test scores over a given period of time. The amount of time allowed between measures is critical. The shorter the time gap, the higher The higher the correlation, the longer the time gap, the lower the correlation. Internal consistency reliability. While estimating the internal consistency reliability, a single measurement instrument is used or administered on a group of people on one occasion to estimate reliability. In fact, internal consistency reliability indicates the homogeneity of the test. A test is said to homogeneous and holds high internal consistency reliability when all the items of the test measure the same trait or function. The split half method, in which the test is divided into two equal or nearly equal halves, is the most common method of estimating the internal consistency reliability. Parallel form reliability. It is also known as alternate form reliability or equivalent form reliability and comparable form reliability, which requires the test to be developed into parallel forms. One way to accomplish this is to create a last set of questions that address the same construct and then randomly divide the questions into two sets. These two sets are administered on the same sample with a time interval of usually a fortnight. The correlation between the two parallel forms is the estimate of reliability. Actually, it measures the consistency of the examinee's scores between two administrations of parallel forms of a single test. Factors Factors influencing reliability of the test scores. The reliability the reliability of test scores is influenced by both intrinsic and extrinsic factors. The intrinsic factors are those factors which lie within the test itself and tend to influence the reliability of the test, for example, the characteristics of the items, length of the test, etc. However, on the other hand, extrinsic factors are those factors which lie outside its test itself and tend to make the test reliable or unreliable. For example, the environmental conditions, the tendency of guessing by the examinee, and momentary fluctuation or distraction while answering the test, etc. Validity. According to Anesthesia 1968, the validity of a test concerns what the test measures and how well it does so. In short, validity is defined as the extent or the degree to which a test measures what it claims to measure. For example, a test that is used to screen applications for a job is valid if its scores are directly related to future job performance. The correlation coefficient computed between the test and the ideal measures or criteria is known as the validity coefficient. The different types of validity are: first, content or curricular validity; two, face validity; three, construct validity; four, criterion related validity. Content validity. Content validity is also known by other terms such as intrinsic validity, relevance, circular validity, and representativeness. According to Anastasia and Urbina, 1997, content validity is a non statistical type of validity that involves a systematic examination of the test content to determine whether it covers a representative sample of the behavior domain to be measured. In simple words, content validity pertains to the degree to which the instrument fully assesses or measures the construct of interest. For example, does an aptitude test have items covering all areas of aptitude discussed in the scientific literature? Face validity. Face validity is a component of content validity and is established when an individual reviewing the instrument concludes that it measures the characteristic or trait of interest. For example, on a measure of stress, the test would be said to have face validity if it appeared to actually measure levels of stress. In fact, face validity is an estimate of whether a test appears to measure a certain criterion. It does not guarantee that the test actually measures phenomena in that domain. Measures may have high validity, but when the test does not appear to be measuring what it is, it has low face validity. Criterion related validity. Criterion related Criterion related validity is assessed when one is interested in determining the relationship of scores on a test to a specific criterion. In other words, criterion related validity is one which is obtained by comparing or correlating the test scores with scores obtained on a criterion available at present or to be available in the future. For example, employee selection tests are often validated against measures of job performance, the criterion, and IQ tests are often validated against measures of academic performance, the criterion. There are two subtypes of criterion related validity. First, predictive validity; two, concurrent validity. Construct validity. According to Anastasia 1968, Construct validity is the extent to which the test may be said to measure a theoretical construct or trait. A construct is a non observable trait such as intelligence which explains our behavior. For example, to what extent is a questionnaire actually measuring intelligence? Construct validity evidence involves the empirical and theoretical support for the interpretation of the construct. Such lines of evidence include statistical analysis of the internal structure of the test, including the relationships between responses to different test items. They also include relationships between the test and measures of other constructs. Construct validity is computed only when the scope for investigating criterion related validity or content validity is bleak. Norms. Test norms consist of data that make it possible to determine the relative standing of an individual who has taken a test. In simple words, norms are statistical representations of a population. The scores obtained after administration of a test is called raw score. However, all these raw scores convey no meaning in themselves. Almost always, a test score must be interpreted as indicating the subject's position relative to others in some group. Norms provide a basis for comparing the individual with the group. Usually, there are two reference points that are applied in interpreting the test scores. The first is called non referencing, and the second is criterion referencing. Norm reference tests are designed to examine individual performance in relation to the performance of a representative group. Criterion reference tests document individual performance in relation to a domain of information or specific set of skills. The norm reference tests, for example, are used to rank each participant with respect to the achievement of others in broad areas of knowledge and to discriminate between high and low achievers, whereas the criterion reference tests are used to determine whether each participant has achieved specific skills or concepts, and is also used to find out how much participants know before instruction begins and after it has finished. Criterion reference tests are related directly to instrumental are directly related to instructional objectives, are based on task analysis, and are designed to measure changes in successive performances of an individual. Criterion reference tests therefore are sensitive to and can be used to measure the effects of instruction. Conversely, norm reference tests generally are not related to instructional objectives, do not use task analysis, and are designed to delineate differences among individuals. Norm reference tests, therefore, are not sensitive to and should not be used to evaluate the effects of instruction. Types of norms. Age equivalent norms. According to Cohen and Swerdlick, 2002, age equivalent norms are those norms which indicate the average performance of different samples of test takers who were at various ages at the time the test was administered. These types of norms are best suited to those traits or abilities which increase systematically with age, for example, weight, height, etc. Good grade equivalent norms. These norms are used to indicate the average test performance of test takers in a specific grade. It is usually a number that describes a student's location on an achievement continuum. The grade equivalent corresponding to a given score on any test indicates the grade level at which the typical student obtains this score. Percentile norms. Percentiles refer to the score at or below which a specific percentage of scores fall. A percentile norm indicates for each raw score percentage of a standardization sample that falls below that raw score. For example, suppose Neha has a score of 35 on the numerical reasoning test, and if 45% of the standardization samples secure below the score of 35, then Neha has a percentile rank of 45 and percentile score of 35. Standard score norms. A standard score or scale score is calculated by taking the raw score and transforming it to a common scale. A standard score is based on a normal distribution with a mean and a standard deviation. Standard score estimate whether a student's scores are above average, average, or below average compared to peers. There are several There are several types of standard scores such as Z scores, T scores, 10 score, deviation, IQ, etc. Types of test intelligence. The term intelligence quotient or IQ was first coined in the early 20th century by a German psychologist named William Stern. This first intelligence test, referred today as the Binet-Simons scale, became the basis for the intelligence test in terms of Administration intelligence test is broadly divided into two categories: individual and group intelligence test. An individual test is one which can be administered on a single person at a time. The Binet-Simon scale is the first individual intelligence test. The two very important individual intelligence scales of intelligence are Stanford Binet scale and Wechsler scales. The group intelligence test, on the other hand, is one which can be administered to more than one person at a time in a group. The Army Alpha and the Army Beta test was the first group test. Examples of group tests are multidimensional aptitude battery, the cognitive abilities test, and the scholastic assessment test. Intelligence tests can be classified on the basis of the nature of items used in tests, such as the verbal, paper pencil test, and the performance test. A verbal test is one in which the items or the questions of the test are in written language form, and the respondent has to answer them with the help of a pen or pencil on a piece of paper. Such tests are also called paper pencil tests. The verbal test can be administered on a group of participants, but only literate people can take up these types of tests because it involves the use of paper and pencil to answer those questions which can only be understood by a literate person. A performance test, on the other hand, is the one where there is little or no use of language, the test materials being designed to elicit manual or behavioral responses rather than verbal ones. These types of tests can be administered both on literates and illiterates as well as on preschool children's culturally deprived and speech defective people. The other category of intelligence tests also includes the non-verbal or non-language tests and culture-free tests. Aptitude tests indicate performance that is the product of multiplicity of experiences of everyday life and therefore indicate the effect of learning under unknown and relatively uncontrolled conditions. In simple words, an aptitude test represents a person's level of competency to perform a certain type of task, or it attempts to determine and measure a person's ability to acquire through future training some specific set of skills, intellectual, motor, and so on. Aptitude tests are broadly divided into two categories: multiple aptitude tests and specific and special aptitude tests. Multiple aptitude tests are often referred to as batteries instead of tests because it tends to measure several aptitudes, each by an independent subtest. The differential aptitude test, or DAT, is one of the most common multiple aptitude tests. The battery has been developed by Binet, Seashore, and Westman and comprises 8 subtests including verbal reasoning, numerical ability, abstract reasoning, mechanical reasoning, clerical speed and accuracy, space relations, spelling, and language usage. Special aptitude tests, on the other hand, are those tests which intend to measure special abilities at a time, such as mechanical aptitude test, musical aptitude test, clerical aptitude test, and creativity test, etc. A personality test is a questionnaire or other standardized instrument designed to reveal aspects of an individual's character or psychological makeup. The three most common methods of personality assessment are self-report inventories, observational methods including situational tests, and projective techniques. Self-report inventories. A self-report inventory, also known as personality inventories, is a type of psychological test often used in personality assessment. It is a self-rating questionnaire that asks participants to indicate the extent to which sets of statements or adjectives accurately describe their own feelings, environment, and reactions of others towards himself or herself. Some of the examples of self-report inventories include Minnesota Multiphasic Personality Inventory (MMPI), the 16 Personality Factor Questionnaire, California Personality Inventory, etc. Observational method can be used either in the natural setting such as a classroom, an experimental setting, or during an interview. Behavioral observations are used to get information that cannot be obtained by other means. The value of behavioral assessment depends on the behaviors selected for observation. The observation becomes the basis for assessing the personality traits. As far as observation interview is a concern. The expectations of the observer are conveyed directly or through body language and other subtle cues may influence how the interviewee performs and how the observer records and interprets his or her observations. So, projective techniques are the most common and popular method of assessing the personality of an individual. In projective tests, the participant has to respond to some unstructured situations, which later on reveals his her latent or unconscious feelings, needs, emotions, motives, etc. Thus, this technique gives the participants ample opportunity to project his or her own personality attributes that are latent or unconscious in the interpretation of an unstructured situation. The best known projective test is the Rorschach psychodiagnostic test or Inkblot test, first devised by the Swiss psychologist Hermann Rorschach in the 1920s. Another widely used projective test is the thematic apperception test (TAT), developed at Harvard University in the 1930s. Aptitude scales. Aptitude scales are the self report inventories underlying a large number of statements which directly ask the participants what their attitudes are towards certain things, objects, or the situations. Some of the common attitude scales are Thurston scale, Likert scale, Gutman scale, etc. Interest inventories. An interest inventory is a self assessment tool used in career planning that assesses one's likes and dislikes of a variety of activities, objects, and types of persons. As such, inventories measures only a limited sample or sets on interest. The interest assessed by such inventories are called inventorized and inventoried interests. One of the most popular interest inventories is the strong vocational interest blank SVIB. The other important instrument for measuring interest is Cooder interest inventory.